packet pushers.
Hi, everyone, and welcome to Packet Protector, the intersection of cybersecurity and networking. I'm Jennifer J.J. Manella, here with co-host Drew Conry Murray. On this week's show, we're talking to our guest, Troy Martin, about IoT in the enterprise, and specifically what network and security architects need to know and what we should be thinking about to better secure IoT networks that are showing up in our environments. Troy's been one of my go-to resources because he's spent a couple of decades working with wireless technologies from carriers to MSPs and manufacturers, and has deployed Wi-Fi and IoT systems in all kinds of fun places. So we talk about common uses of IoT in the enterprise and all of the multitude of IoT protocols that go along with that, the security risk, how to mitigate them, along with tools for finding and securing IoT, how to drive security requirements, and even some of the pros and cons of protocols like 6LoWPAN. But first, Drew, let's take a quick tour of this week's headlines.
We've been talking about the Change Healthcare ransomware attack. The story just keeps on giving. Now, apparently, I guess the big issue was there were a couple of organizations that sort of were involved in the attack. The ransomware payment was made to one group. A second group, I guess, didn't get anything, but they also apparently have as much as 4 terabytes of data from the attack. So now they're saying, well, if we don't get any money, we are going to sell this data to the highest bidder.
Yeah. So a few weeks ago, I think around episode 8, we talked about this. And I think we said kind of stay tuned. There's going to be more because AlphaV, which owned the ransomware network, took the $22 million and then ghosted on their affiliate. The affiliate is actually who got into the network and therefore had access, potentially persistence, and then obviously had exfiltrated data. And so I think we've been sitting here waiting to see what that other group that did all of the hard work was going to do, since they didn't get their piece of the pie with this. And it looks like they are now going to extort Change Healthcare to get their little piece.
I mean, in some ways, it seems like they haven't learned their lesson because I guess they're going through a secondary service to put this data out there for the highest bidder. So they could get scammed again, but I guess they're giving it another try. I also wonder, if companies, right now they seem to be paying ransoms, but if they end up having to pay 2 or 3 times or multiple times because of clashes like this, did they just decide not to pay? What kind of impact could that have on the ransomware ecosystem?
I think it's definitely going to change the ecosystem. I don't know how exactly, but if you stop looking at them as criminals for a second and you just think about it as a business transaction,
right?
The fallout is definitely there's going to be some modification of how their relationships work, or maybe even that the Bitcoin has to go when it gets paid to 2 different places, or you start to see if Alfie has, screwed over their affiliates, then they're not going to be warm and fuzzy with the rest of the criminal business units that are out there. So there could be another player that comes into the picture. Maybe there's some type of guarantee with them, or these affiliates come up with their own homegrown ransomware.
Yeah, I have to say, the whole attack was terrible. It crippled essentially healthcare for a few weeks or days in the US, but the infighting among the criminals itself, frankly, I enjoy because they deserve having a hard time.
Get your popcorn.
All right, moving on. The Moon, this is a botnet previously thought to have been rendered inert, seems to be active again. Researchers at Lumen Technologies say they've discovered a fresh new variant that's present and active on SOHO routers and perhaps IoT devices. It's being used to provide anonymity services to attackers. I think end-of-life ASUS home routers appear to be a popular target.
Yeah, so it looks like those Soho routers are the target du jour for this, but they've gone through several iterations. This particular group with this different version of this malware has been around for 10 years, over 10 years. So they've just changed the systems that they target, kind of working that botnet through. But it looks like the growth of this is a little concerning because the proxy service behind it called Faceless, and Brian Krebs has a really neat write-up on that whole group and what they do. And it just goes deeper into that. But basically what they're doing is, running a malware anonymity network where it's a botnet where they've taken over devices. And so they can route traffic to and through those and or set up, proxy services. So it just puts an attack logically closer to whatever it's hitting, and it obscures the true source of it.
Yeah.
So basically, if somebody's getting attacked with something, you can't really tell where it's coming from. I think one of the numbers I saw is that Faceless proxy service is able to accommodate now 7,000 more users a week. So if users here being criminals, that's 1,000 people a day growth using this network.
Yeah, it's not Facebook numbers, but it's big and concerning.
Troy's always the polite Canadian over there. What do you think about this one, Troy? I know they're kind of loosely throwing around IoT, but you come from a carrier space a long time ago, so you've seen these issues, I'm sure.
Yeah, obviously, it's advantageous to grow the size of your botnet, giving you more opportunity to rent it out and attract more of those criminal types as customers. But I suspect I haven't read the article in depth, but I suspect it has to do with a lot of default configuration put in place, and users just unaware of how to configure and secure their IoT or their legacy ASUS home routers
Right.
correctly to mitigate or prevent these types of attacks against their home systems.
Yeah, I find it frustrating because I feel like it's another example of device manufacturers essentially passing on the costs and the efforts of risk management to everyone downstream of them, their customers and everybody else who's on the internet, because this provides an attack surface that people are taking advantage of. It's kind of like, an old factory that has drums of toxic waste and the factory shut down, but that toxic waste is leaking to the groundwater. Who's responsible? And it seems like there are no consequences for device manufacturers to behave like this.
Get your toxic Soho routers off my land.
Exactly.
And a few weeks ago, because it was just February, right? So a few weeks ago, similar story, different targets. I think those were Ubiquity routers at that point in time. So, and it at some point, the federal government has stepped in with some of this when it's been tied back to national foreign intelligence gathering against critical infrastructure. They have mitigated some of these issues, but yeah, we need to do a little bit better here. It really shouldn't be that hard. And
Yeah.
speaking of doing a little bit better, there's also on the cellular world, switching gears a tiny bit there, there's two wireless protocols that the FCC wants some feedback on, especially from the telecom community, about how they're fixing these protocols. So, Drew, why don't you kind of fill us in on the details of that?
Yeah, so the two protocols are Signaling System 7 or SS7 in diameter. They are used in mobile wireless networks. And I guess there are vulnerabilities in the protocols that could let attackers track user locations. So the FCC is asking communication service providers for information about how these providers are addressing those vulnerabilities. Right now, it's just a comment period. There's no potential action or repercussions. It's just, I think, a data gathering issue. And then perhaps there will be some follow on steps that have to be taken.
Yeah, and I'm so diameter is authentication, authorization, kind of like the big brother to the radius servers we use inside of our organizations. And then SS7, I believe, is routing. And Troy probably knows way more about this than any of we do. But I believe that's the routing for cellular. And so specifically, this is talking about not as much the data side, but all of the phone calls and SMS and the things tied to that. So this is a little bit concerning to me. I don't think it's anything new. I think we knew these vulnerabilities existed in varying degrees. But the fact that the FCC is asking maybe people what they're doing about it on the telecom side instead of being a little more forceful about the expectations for those telecoms to secure user traffic. This has been already exploited numerous times, targeting several people within the federal government at high levels. So pretty interesting. Troy, do you know any more about SS7?
So this is actually quite concerning. I think one of the challenges I find with telco is instead of patching a lot of their protocols, they just lobby to get things made so that it's illegal to launch attacks against their deficient protocols. But SS7 is essentially it's the out of band protocol that's used for routing, setup, teardown of calls, call forwarding, caller ID is part of this. So conceivably, it could make it easier for people to start spoofing where calls are coming from, spoofing text messages to prompt people for password resets,
Mm.
um, or get in between those two-factor authentication validations of codes that are sent. So there's a lot of potential concern here.
And it's interesting that you said that because you kind of gave a list of different vulnerabilities and risk associated with that. And the FCC seems very zeroed in or zoned in on location, like protecting the privacy of the user's location. But like you just said, especially between those two protocols together, there are so many other risks and attacks associated with vulnerabilities in those. I'm interested to see that. So you guys are hearing this. You've got a few days if you work in that space and you want to provide some comment and feedback to them. You've got a few days to do that, and we'll drop the link in the show notes for you.
And we're recording on April 11th, just for those of you not in front of a calendar.
So, Troy, let's get into the meat. Let's talk
Yeah.
about IoT protocols, specifically like the security risk and what today's network and security architects need to be thinking about. And I think we want to just start with kind of getting a lay of the land because I think most of our listeners are going to be familiar with Wi Fi. But what would you say, like the top handful of non Wi Fi wireless technologies prevalent in IoT are going to be?
Yeah. So before jumping into a bunch of the other IoT protocols, because if they're familiar with the saying that the great thing about standards is that there's so many to choose from, the great thing about IoT protocols is there's also so many to pick from. So specific to the Wi-Fi family, I want to give a shout out to the Halo protocol, 802.11ah, which is the Wi-Fi's branded term for their IoT specific protocol that has a lot of tweaks and features that make it ideal for IoT deployments. But there's several IoT protocols that are all derivatives of the IEEE 802.15.4 standard. So they're based on that. So things like Zigbee, you may have heard of Thread, Matter, Wireless Heart, and ISA 100.11a are also based on 802.15.4. But those two protocols tend to be more focused for the industrial space.
Mm.
Then there's other IoT protocols that their sweet spot is extended range. So we're talking 10, 15, 20 kilometers. World records have been set at much, much longer distances than that. But things like LoRaWAN, Sigfox, and then circling back to the news article in the cellular space, other IoT protocols like the narrowband IoT or LTE-M, which are carrier-based LTE protocols that they try push along with monthly subscription fees. And then there's other protocols like Z-Wave or Z-Wave, depending what country you're from, how you pronounce that. Retail protocols like the NFC that you use for a lot of payments.
Mm.
And if you're into sports and fitness and a lot of your personal trainers, you may have heard of the ANT or the ANT Plus protocol that allows you to connect your biking or your cycling trainer to your iPad or Apple TV as you virtually race.
Oh, that's what that little logo is on the treadmills that I don't use.
Yeah.
So, what do we owe the profusion of standards to? Is it because, there are such a multiplicity of use cases that folks came out to develop a standard for each specific use case? Why so many protocols?
There's so many different types of applications that you could leverage IoT technologies for. And depending on those environments, there's a lot of tweaking and tuning of the protocols for a lot of the purposes. So if we're talking about security, as we are in this podcast, I'm sure all the listeners are familiar with the CIA triad, the confidentiality, integrity, and availability.
Mhm.
Well, one example of this is in the industrial side of things, they like to switch the letters around to re-emphasize their importance. So they often call it AIC, emphasizing availability, then integrity and confidentiality. And for them, if they send a message to close a valve, they want to make sure that that message is received by that end actuator and the valve is actually closed.
Hmm.
Right. Then they're worried about integrity. So if you have a giant tank farm and you need to turn off that valve so the tank doesn't overflow and create an environmental disaster, you want to make sure that when you send the message to close the valve, that the message close is actually what's being sent and delivered,
Right.
that it doesn't get, bit swapped and it actually keep the valve open and it keeps filling. And the last one, confidentiality, they tend to believe that it doesn't matter if you see me sending a message, open and close a valve, that's fine as long as it gets there. I'd still be a little bit concerned about this because if we keep telling attackers that we're opening and closing valves and we keep performing this at the same time every day, or it's the same structure or same pattern, it gives predictability, which allows them to plan out attacks and kind of figure out when there's opportune times to sneak in extra frames or try and manipulate the data in flight.
Okay, so the idea is it's not necessarily sensitive data like a credit card number or health information or something else being transmitted, but even that signal can provide information, even if you can't do anything with it at that moment.
Yeah, if you're always taking a reading at the same time every day, that could be a good time to jam the signal. So it prevents readings from the IoT network from coming back into the system.
Like social engineering attacks when somebody always drives the same way to work or they always go to the same coffee shop and you know where to go, chat them up.
Exactly. It's that predictability and that planned type of attacks that you can carry out, which I think are quite concerning that often get overlooked, especially when people are playing the long game.
And Troy, you mentioned you rattled off a lot of letters and numbers and let me kind of rewind there. So we talked about some of the long range stuff, which was I think LoRaWAN and Sigfox.
Mhm.
We talked about the cellular IoT protocols, the NB-IoT and the LTE-M.
Mhm.
Let you pull out a few of the others, I guess, and ask, what is used where? Obviously, the long range things are used for long range where we need bigger distance. But what these groups of protocols and standards, where are they being used in what capacity? And what are a few examples of that?
Yeah, for sure. So one that I forgot to mention that I just caught now was BLE, or Bluetooth Low Energy.
Yeah.
And that's a technology that's often seen in retail shops. So think like grocery stores, shopping centers, that kind of thing. And all those little tags that are in front of every little product that you see on the shelf. At night, someone's printing new labels and replacing them with a new price or a promotion, or moving the different parts of the shelf as inventory gets restacked. And you have dedicated people spending a whole evening making these changes. So they've come out with smart tags that use e-ink technology. And now you can push out over BLE, you can update all these tags. You can even have things like flash pricing, where if there's enough people in the store and for the next 15 minutes, you can change the pricing on certain items. But all of this information is sent in flight over a wireless IoT protocol, the Bluetooth Low Energy. And so if you were able to compromise that system, you could affect pricing or rearrange items on the shelf, um, cause a disruption in service, flood the customer desk with people complaining about pricing. So that's one common case for BLE as an IoT technology. Zigbee, one of the other ones I mentioned, it's used in a very popular home lighting system that you may have heard of, where you can turn on your lights, turn off your lights, set theme mood lighting with various coloring. That's controlled by Zigbee systems. And one of the ways that they secure that as you connect new lights to your system is you have to push a button on the gateway. And when that button's pushed, the system then gets ready to accept a new device being added to the system, or several new devices. Now, as those devices are added, they're often preloaded with a default key. So it does require you to physically push a button to trigger that join acceptance mode.
Mhm.
But the key that's used is a default key. And what's interesting is once you know that key, and if you do a quick search on Google, you can find it, and it's something like Zigbee Alliance '09 in hex. And if you were to take that key and plug it into Wireshark, and if you captured Zigbee traffic, you can decrypt that traffic that you captured in Wireshark. So Wireshark natively allows you to decrypt Zigbee as well as other IoT-based protocols within that packet analyzer.
And I love that you mentioned the default keys because one of the things, people ask all the time during consulting engagements is, which IoT protocols are secure and safe to use. I know we always like to say it depends, but so many of them have security mechanisms written into the spec, but the products don't implement them. There's no enforcement or testing of how the product chose to actually work that into the platform. And so the key rotations, the exchanges, the joining, the meshing, all of that, the easier it is, it seems like as a user, the easier it is, the less secure it is typically. But there's always, that kind of tipping point. Okay, so we've got BLE with the smart tags. We've got Zigbee with home lighting. What are a couple of other examples that we might see in the enterprise?
Yeah, so we're also seeing this embedded in some of our smartphones, the Thread radios. Right, so we're seeing that technology up into place, but something that's I think a little more exciting is the evolution of all these IoT protocols. So, Drew, you were asking about earlier. There's a whole mix match of these, and where would we want to place or find them, or how would we use them, and how they evolved? Because there's so many different protocols, they're relatively young compared to other networking protocols, so we haven't had that convergence
Mm.
to seeing which protocol will be dominant. If you kind of think it akin to the old VHS wars that we had many, many years ago, we're seeing Matter as the overarching protocol that's going to bring a bunch of these IoT protocols together, so that we can tie a bunch of systems together, that they use the same command and control instructions. Many existing platforms, it's just a matter of simply pushing a new firmware update to what would have been a legacy system, and then making it Matter compliant. Other systems are so old that we may have to put in little Matter bridges that allow us to talk to that legacy IoT system, and then it bridges it into the Matter format and structure that then we can leverage as part of a bigger ecosystem.
What kind of enterprise devices would be using Matter? Are we talking like security cameras, sensors, that kind of thing?
I think that you'd see it more in things like building control and automation.
Okay.
So HVAC systems,
Hmm.
lighting systems, like we were just talking about, or you could have hotels could start using this, right? So when there weren't people in the room, they could automatically close the blinds to reduce cooling fees,
Right.
things like that. Or when a guest just checked in, they could open the blinds so that when they walk into the room, they get a great view of the parking lot or some scenic view that they have on the one side of the building. But all these different IoT systems, all managed by different IoT protocols, there was a significant challenge in getting them to talk and interact with each other. And I think Matter is going to be the standard and protocol that brings a lot of these systems together, especially in the enterprise and the residential side of things.
So if I am a network or security person and IoT is in my remit, obviously Wi-Fi I'm going to be paying attention to, but Matter should be something maybe I want to be looking into, getting an understanding of how it works and find out if it's actually in my environment.
Yeah, absolutely. And I think Matter sits, if you kind of compare it to the OSI stack, it rides a little bit higher and it basically enhances lower layer protocols.
Okay.
You definitely want to be aware of that. And I think it's coming, it's part of the future. But as we see these networks deployed, we still want to be mindful of enabling the security options that are available as part of that protocol suite. A lot of the manufacturers, which is typical when you see people doing like speeds and feeds test, or how long does it take me to deploy this IoT network? Can I turn it up in 5 minutes and get everything working? When components are subject to those type of tests, manufacturers want to put as few hurdles in the way as possible to getting devices connected.
Yeah.
And so they either turn off security by default or leave in default passwords. And I don't think they do a good enough job to emphasize that you should be changing the default password, or you should be running this audit of your configuration to see if it's meeting a minimum threshold cybersecurity compliance. And so there's organizations that do publish checklists and sequences of checks that you should go through to make sure that your IoT deployment at least meets the minimum standard. So NIST has a lot of documents that you can check out for things like this specific to IoT and cybersecurity. So having built-in checks as part of the dashboard that says, hey, when I'm ready to go live, if there's like a little audit that I could run against my network, to give a little display saying, hey, you're deficient in this point, or you haven't changed default settings, you haven't enabled encryption, or your bit key is too short, and it should be something else to be more robust.
I was going to ask a little bit more into Matter. So the other CSA, the Connectivity Standards Alliance, which is, I think, where Zigbee has lived, now is sort of the mothership or group that's managing the Matter protocol. And it's, Matter, just like you would think it'd be spelled. And I believe that is also one of the ones based on 6LoWPAN. So Thread and Matter are both kind of based on a condensed IPv6 stack, basically. So in my mind, as a security person, I tend to guide people towards those protocols because we know IPv6 and we have the visibility and the control in that stack that just naturally follows what we have in the enterprise space. Whereas some of the other protocols, we don't have the same tool set for natively within our environment. But I'm curious, like, how do you see the trends and adoption of, Zigbee versus Matter versus Thread for enterprise purposes?
Just a brief pause to ask, did you know Packet Pushers has a job board? Whether you're looking to find or fill your next great IT infrastructure role, the Packet Pushers job board is the place to go. It's easy to post, easy to browse, and easy to apply. So whether you've got IT talent or you're looking for IT talent, visit jobs.packetpushers.net and get to work. That's jobs.packetpushers.net.
So it's interesting with Matter because it's rolling in a lot of the various IoT protocols. Zigbee is becoming part of that. So just because it's Matter, it won't necessarily mean that it's 6LoWPAN based, or that it even has IP addresses on all of your end nodes. And in fact, I've heard some manufacturers describe their IoT protocol, so Wireless Heart in this case, is it's more resilient to attackers because it does not natively support IP connectivity direct to the end nodes. An attacker doesn't have direct access to it, where if something had an IPv6 address, it's potentially directly reachable from a compromised asset on the network. So you could look at it as maybe we have extra protections by having to bridge from IPv6 to some other proprietary IoT protocol to have to go through the gateway. The other part of that conversation is by going through that gateway, that becomes your bottleneck or your weak point on the network.
Right.
And a lot of these gateways are running some form of web server, which sometimes becomes a few patches behind, or they have open ports that are needlessly left enabled, giving attackers a route or a foothold onto that gateway device itself. Now, from the gateway, they may not be able to compromise any of the IoT nodes, but it still puts them in the path in the middle. So all the data going to the actuators or coming back from the sensors, that data can be manipulated, either outright blocked or the value of the data can be changed. Going back to our conversation about valves, where we can, fake it being closed when it's still actually open.
So this gateway is just a device, maybe an appliance that's sitting there doing protocol translation between whatever those IoT things are talking and then whatever it needs to be talking on the data network
Could
gateway
be
is
a
doing here.
dedicated appliance or some sort of virtualized server package on the Wi-Fi side of things. Whenever we see the Wi-Fi vendors checking that box that, hey, we have an IoT radio in our device. Yeah, sure, it has like a 802.15.4 based IoT radio, which are the common ones that we'd see, or BLE. But without that software module to perform that bridging function, it's of limited value to us. So we're seeing some Wi-Fi access points or vendors now provide that software that can run as a virtual instance on the access point to act as that bridge. But it's that software piece that becomes the weak point.
Okay, so it doesn't have to be a dedicated appliance. I can run this sort of gateway software on an AP itself. That AP then becomes a gateway to do that protocol translation between my IoT devices and the rest of my wireless network.
Yeah, exactly. Yeah.
Okay. But then again, that also introduces, as you said, a bottleneck and potential vulnerabilities because it's increasing my attack surface.
Yes. Yeah. Now, someone would need access to the network itself, so they'd already have to have a foothold in your network to attack the gateway on from that side. They're not coming in from the IoT sensors themselves. Generally, those protocols, if configured correctly, the right encryption keys, their join keys have been secured as they've onboarded new devices. They generally don't have the same ports that are available, or software services running on different protocols. So it'd be an attack from the network side against the gateway. And I'd argue that if an attacker already has that level of access to your network, there's probably other things you need to worry about.
Yeah, just a bigger fish to catch and fry there. You mentioned, some of the Wi-Fi APs that have these gateways in them. In my experience, sometimes different teams that are not the IT team end up procuring these things and sort of installing them and getting them up and going, whether it's somebody that's a digital transformation officer or it could be, an OT or an operational team who just has some specific product or set of equipment that they have to get going. And IT is not typically involved in all of those. And then I've heard of some organizations where they just put anything wireless, within the IT group, and so the network administrators know what's happening. I'm curious, like, what have you seen as a split in that? Is these things that are not Wi-Fi that you've worked with, are those projects typically managed or initiated by the IT teams, or are they coming from some other group or department? And then if they're coming from some other group and department, how do those of us that need to worry about, diagramming and securing these things kind of get involved in that conversation early?
I find what often happens, and I do a lot of work on the industrial side of things, is you'll have an operator who's interested in getting vibration information, or a business unit wants to get that vibration information to monitor vibrations on a turbine or a generator, something like that. And the reason for wanting that data is allows them to do predictive maintenance, and they can plan scheduled outages and that kind of thing. So there's tremendous cost savings from getting access to that data. And they do a search on the internet. They look for some vibration monitors that'll give them the resolution that they're looking for. They have the gyroscopes that are sensed enough to take the readings. So it's not just any old vibration monitor out there. They're looking for a specific vibration monitor that meets all their requirements. They'll go out and procure that, and then they contact their instrumentation teams to run around, deploy a handful of sensors for a proof of concept to make sure they're getting their accurate readings and bringing in the data that they need. And while they're doing all this, what they fail to do is reach out to the networking teams, whether that be the IT team or the network specialist as part of the OT organization, and they get their devices connected. And we talked a little bit about gateways earlier. One of the cool things about gateways and those physical appliances is they have multiple backhaul uplink technologies that they support. So it could be Ethernet, could be fiber, It could be cellular or Wi-Fi, right? And so if there's already Wi-Fi in that environment, they'll connect their gateways to the existing Wi-Fi network. And what often happens at these plants is there'll be a guest network, there may be a production network, there's an enterprise network, maybe a miscellaneous network with a pre-shared key, and they'll just pick the wireless network or the SSID that's the easiest one to connect to,
Mhm.
right? Which could be guest or a random pre-shared key network that they have.
The least secure one often.
Yeah, yeah, most often, yeah. So they'll connect that to that, and then it's difficult with all the devices being connected for the security team to start limiting access of these devices. So now you have this random IoT network that's connected, and you're not really sure what it does. And you can deploy a lot of systems, which I do recommend to my customers. Things like the ICE, the ClearPass type systems, where they're monitoring what devices are connected to which ports.
Mhm.
Now, this works well, I find, in the IT side of things, where if there's a restricted device or an unknown device that connects to your network, you block and lock down the port and disable it. And that's a good news story in the IT side of things. But in OT, if it's a business critical device that gets plugged into the port and you start turning down these ports, you may inadvertently shut down the entire manufacturing process.
We
Right
like
now,
to call that a resume generating event.
right, right. But it sounds so good from the security side, and you think you're doing a good thing, but the downside is that not only are you out of job, but you've also shut down the plant, which could impact the bonuses for all your peers.
Yeah. I'm imagining like the whole IoT network behind the IT network and the wireless. Like, was it Men in Black where he opens the locker and there's like the whole little world, like little teeny tiny, like they're living their own world, like they're
Yeah.
inside of the locker and they don't know that they're inside of a locker in this world. That's what comes to mind when I think of a whole IoT infrastructure just kind of tucked behind the wireless or the wired infrastructure.
Mm.
But it sounds like you're saying this gateway is where sort of the IT and the OT worlds interact, and that's maybe the entry point for the IT team to start having conversations with OT.
Yeah, that's the device that the IT networking teams would detect, would be the presence of this gateway.
Mhm.
They wouldn't know how many necessarily IoT devices were behind it, but hey, what's this new gateway? How much traffic is it sending? Where is that coming from? Why is it on the guest network? Why is it always up? Like, why
Mhm.
doesn't it leave after a period of time?
Right.
So there's weird kind of going back to that trending and predictability. Seeing things like that could give them some insight to try ask more questions.
Okay.
Yeah, so many people just don't even look at the guest network, and that would just fly right under the radar for a while.
Hmm, hmm.
We talked about common IoT being used for like HVAC, lighting controls, and so on. So in a building that your company is leasing and the facilities management, which you don't have any influence or control over, is running the lighting system, the HVAC, and so on with IoT. Does that present a risk to you as a tenant in that building? Like, could that IoT network become a jumping off point to get onto your corporate network?
Yeah, so if they were isolated systems, depending how they're all connected in the background, it may not be a concern itself if they were in fact, air gapped between the two.
Mhm.
But what I might be more concerned about is irritation of my employees, right? If they had remote access where they could turn the lights on and off at different intervals during the day, which cause a work disruption,
Right.
or if they could increase the temperature, now people aren't being as efficient or as productive during the day, or it's driving more complaints, or maybe by controlling the lighting, that's the distraction that they need to gain physical access somewhere else in the building. Right. So it does create an attack vector, which could be the distraction for something else.
I see. So an attacker could take over the building control systems to disrupt some activity going on with the tenant, you're saying?
Yes, absolutely. That's entirely possible.
Okay, and that's a more likely vector than using those building control systems as a jumping off point to a tenant's network within the building.
Yeah, because now you have to imagine if you have your building manager managing multiple properties,
Mhm.
hopefully they have someone on their team as part of their IT team monitoring security of their HVAC lighting control networks at their various sites. And if they don't have that resource there, how are they going to detect that their IoT network for building management has been compromised?
Right.
Right. So I'm not sure if they do. Hopefully they do have someone monitoring that. That could be a problem. And now you're kind of disconnected from that loop. But at the same time, a lot of tenants moving into buildings, do they worry about the power feed coming into the building, making sure it's coming in from, two different corners of the building if they have multiple power providers? how they're set up for backup power. So
Mhm.
I guess as a tenant to that building, how much control do you want over that environment? Sure, there's a network there, but should the tenants be in control of every network that exists in their system? Maybe they should, maybe not.
In non-shared office spaces, I mean, the HVAC system was exactly how Target was breached some, what, 10 years ago.
Right.
If it's an organization that's managing or an enterprise that's managing their own infrastructure and building facilities, I think nobody is as segmented as much as they want to be. And at least the organizations, even the ones I work with that do, crazy network access control and zero trust stuff, there's always room for improvement. And the vast majority of organizations often aren't doing really any meaningful segmentation. They might have different networks. They're not filtering the traffic between those networks and monitoring that in any meaningful way.
Yeah, I'm also thinking of a case a while ago where at a casino, I think it was a sensor in a fish tank, a temperature sensor in a fish tank
Yeah.
was exploited to find their way onto the actual casino network. And I don't remember quite how it happened, but now I'm thinking there was probably a gateway involved. So there are potential vectors here.
And that's where like having all of your sensors IP enabled or having them all connect via Wi-Fi, right? Where it's not necessarily a proprietary or completely locked down protocol that
Mhm.
provides avenues to get into a network. Whereas something like a Zigbee, like you'd have to join the Zigbee network, or wireless HART, you'd have to be part of the mesh, an actual node that exists on it, be assigned a slot as part of the super frame. It's more difficult for those IoT type technologies, but something like Wi-Fi, that's an attack like that is definitely possible.
Yeah. So you mentioned Zigbee, Thread, Matter, Wireless Heart, BLE, and also you mentioned Wireshark. Do I need special tools to be able to do a survey of my environment to find out just what's on there, or can a typical wireless survey tool tell me what I need to know?
Yeah, so you definitely need tools. And from my standpoint, I don't think there's a typical tool for the IoT side of things. I think it's relatively young in that regard.
Mhm.
There are some Wi-Fi based tools that happen to have 2.4 modeling engines already built into them for the Wi-Fi radios.
Mhm.
They're used to design IoT deployments that also operate at 2.4. Something like Zigbee, Thread, the Wi-Fi Halo, that kind of thing. They're all at 2.4.
Okay.
Some of them are also building in support for sub 1 gigahertz protocols operating at the 915 band or the 868 band, things like that. And that helps out with design. But in terms of discovering devices that it may exist in your network, and a lot of the customers, almost pretty much all the customers I work with, you have initial conversation with them asking about what existing wireless technologies they have on site. They almost always say, well, we don't have anything. In fact, we have a policy against wireless at this site. And like, okay, that's interesting. Let's do an audit. Let's confirm this.
Mhm.
And 90% of the time, we find some other wireless network that they weren't aware of operating on their site with some sort of device. And they're like, oh, that's new. And like, we've wondered what that was. Like they've seen it and they have questions about it and they're still wondering. So there's special hardware that you can get. So it's fortunate that a lot of the IoT protocols are 802.15.4 based, right? So little USB adapters, you can get something that reads the frame format of
Okay.
802.15.4,
Mhm.
and then there's some other software you can read the frames and do various packet captures with that. Some of the protocols, like Zigbee, for example, behave similar to Wi-Fi in the fact that it picks a channel and stays on that channel. Right, unless there's too much interference or some other reason to move, but it stays there. And with the 15.4 protocol, there's 16 channels on 2.4. They're all 2 megahertz wide, 5 megahertz spacing, so it picks one of those channels and it lives there happily. When you control or you set up your lighting system, one good practice to avoid interfering with other wireless systems is to perform channel management. And Zigbee, although it supports 16 channels, 4 of those channels fit in between the gaps of the non-overlapping Wi-Fi channels.
Mhm.
So you can pick those channels for better coexistence. But that's about as much configuration as a lot of these systems have. You have limited ability to change the default password on some of those lighting systems or change the key types or the key strengths, turn security on and off. A lot of those configuration knobs and whistles just aren't there, right?
And then there's the whole external facing thing. I know, you know, Shodan is a great resource for checking to see what you might have looking out into the public internet that you didn't know was there, and paths back
Mhm.
in. And I know on the OT side, when we look for things, there's all sorts of interesting things you can directly access there. Same thing, I'm sure, with some of those lighting controls.
Yeah, yeah. And like wireless hearts also uses 802.15.4, but it hops around the channels. So it's hopping across it doesn't use the 16th channel, just use the first 15, but it hops randomly across those channels. So in order to perform a packet capture there, you'd need some sort of device plugged into a hub where you had multiple radios listening on all the channels all at the same time so
Wow.
that you could recover the wireless heart stream. So it makes packet captures and detection a little bit trickier, but it's definitely possible to see what's out there. But there is a lot of dedicated hardware to make that happen.
So some of the cellular stuff, of course, is a little more, maybe the barrier to entry and learning, and getting tools for that is a little bit higher. But some of these other things, if someone is looking for resources to learn, just get their hands on a little bit of experimentation. Are there books or blogs or kits, training or anything that you recommend?
One, there's a book written by Dave Kennedy, Practical IoT Hacking, which gives you a great gateway into the world of IoT and gives you some ideas of what you can do. He has a lot of examples through the various chapters. On the industrial side of things, there's a whole suite of courses from the SANS Institute focusing on industrial cybersecurity. So if that's your niche, if you're into like the SCADA systems and all that kind of stuff, that's a fantastic track to check out. There's a lot of resources written by the federal government and the federal bodies that have documents defining thresholds and checklists and minimum standards that you should be looking for. Some of them focus a lot on what the manufacturers should be doing. So giving recommendations to them and also people implementing those systems, how they should be configuring their setups. For more of a hands-on perspective, there's things like the IoT Village at conferences like DEF CON,
Mm.
where you get great hands-on experience by geeks who just want to play with technology, explore, and have fun. So those can really go off the rails quickly, but that's a great place to check things out. So lots of resources out there, a lot of people writing blogs. Obviously, this podcast is a excellent resource for that, but there's some other industrial-specific wireless IoT podcasts that are out there that you can follow.
You mentioned some of the federal checklists and sort of minimum requirements, and I know we've recently come out with, on the consumer side, the Trustmark, Trust Shield, I forget what they've called it now, but it's really for the consumer IoT manufacturers to sort of opt into doing a little bit better job educating their users and providing services and support to them. So on the enterprise side, I haven't seen anything quite like that yet. I'm curious, with the organizations you've worked with, do they even consider security and how they're gonna operationalize these things? Or do you really get kinda pulled in after the fact when they've picked the technology? What are they considering if they're going beyond just, "Okay, here's the one sensor," if there are options for different protocols or manufacturers, what's their thought process in choosing?
Yes, a lot of the end users, so going back to the retail example of those smart tags, they'll pick a tag that has the screen size that they're looking for or the battery life that they're looking for. So they don't have to change the battery once a month or every 6 months. Maybe they want it to last a whole year. So they'll look for the tag or that sensor actuator IoT device that they're looking for. And they don't care if it's Bluetooth or if it's LoRaWAN. This is the device we want. You as a network operator, you need to figure out how to get it connected. And if that means leveraging, the LoRaWAN technology and deploying a gateway or multiple gateways, you have to get that set up. It's very often that you come in late to the game to try drive the thought that if you're picking a sensor, not only do you want it to have this battery performance, the screen size, the ability to detect vibration with all these other parameters, but we also need to support this level of encryption, or it needs to support, minimum AES 128. It needs to have the ability to change any default passwords, turn on and off any ports, reasonably push firmware updates to patch things as they come out. And unless you're early at the table to drive these requirements in as part of their selection, it often happens after the fact, and the business has already selected the device that they want to go to, and they've committed dollars or they've already purchased, tens of thousands of these units, and they can't go back on that. And now you're forced to make a compromise, right? Where if you can get in earlier and say, hey, this is our policy requirements, this is our minimum standard, and it's been signed and it's being backed by one of the senior executives, Well, now you have a lot of weight to push back on them and said, no, you picked the wrong sensor. We have executive sign off that says your sensor is not compliant with our corporate standard. You need to go pick something else. So that can help in a lot of these situations.
Yeah, executive sponsorship is always the way to go.
Yeah.
So, Troy, we got some resources you recommended. Are you social? Do you do things online? Where can folks find out more from you?
I am on the socials. Probably the easiest way to find me is on LinkedIn. I'm also on Twitter at TroyMart, so you can find me there. I do blog at wifivita.com, so you can check out some of my articles. It's a mix of wireless, IoT, and sometimes I'll talk about whiskey. But I also do teach some IoT classes at the WLPC conference. For the last few years, I've been teaching a class I co-developed with Raymond Hendricks, LoRaWAN Bootcamp, where we walk students through the LoRaWAN protocol itself, as well as giving them a series of hands-on labs so that they can build their own LoRa gateway, which connects a mix of different LoRaWAN devices. And then we also build the network and application servers that go along with that, ultimately ending up with some dashboards and graphs that they can review the data that's coming in from those sensors.
Yeah, I saw that for pieces of it the first time at the last one and was really impressed with what you guys are doing there. Really cool.
Yeah, we're excited about it.
Troy, I feel like we just scratched the surface on IoT, but I appreciate you giving us this introductory course. This is really helpful. So we want to thank you for being here. And thanks to you for listening for another episode of Packet Protector. You can find us and subscribe wherever you get your podcast. You can connect with JJ and with me on the Packet Pushers Slack community. We've got a general Slack channel and a channel dedicated to Packet Protector. You can go to packetpushers.net/community. And if you want more nerdy goodness on networking, wireless, cloud, network automation, and more, go to packetpushers.net, where you'll find thousands of hours of free technical content for your listening pleasure.